Hello everybody, my name is Govinda Fichtner. I want to talk today about Docker at AWS. Who's AWS user here? Okay, we have some users here, good to know. I've been a DevOps for the last 10 years and currently I work for Pessler AG in Nuremberg as a cloud architect. And at Pessler we are producing a software called PRG. PRG is a network monitoring software which administrators use to monitor their IT infrastructure, and we develop it and sell it all over the world. That's how PRG looks with different clients, and my team especially is responsible for developing and maintaining a SaaS platform where we provide PRG as a monitoring service to our customers. So they can just sign up for a subscription and then just start working. The back end of this service is built entirely with AWS, and that's why we basically do a lot of stuff with AWS. The agenda for this talk is made of 4 parts. The first one is I want to just have a short glimpse at the Docker architecture. Then I want to have a look at some AWS concepts and terms, just to make sure that we are all on the same page. We just saw that only a smaller number of people here obviously did work with AWS before. And then we're going to look at the different options we have with running Docker and containers in general at AWS. And at the end, we're going to wrap it all up by having a look at the different criteria we can have to basically decide what of the available options is the right one for our use case. Yeah, looking at the Docker architecture, yeah, it's pretty easy. I think most of you know this already, but just to remind everybody, we basically have a Docker host usually where we download images from a container registry, and then we run these images as containers. Yeah? And we work on this Docker host usually with a client. Yeah? This can be the Docker CLI, but it can also be some kind of API, some kind of other software we use. Yeah, coming to the AWS terms and concepts. Basically, AWS is a huge infrastructure provider with a global presence. So AWS has a concept called regions all over the world. They have regions, and in these regions, for instance here in the US, they usually have a couple of so-called availability zones. And these availability zones are basically data centers which are just some kilometers apart from each other, so that when disaster strikes, not everything is down. And currently we have about 20 of these regions. And if you look at this diagram, you see the aspect ratio obviously is wrong with this monitor or beamer. But if you look at a region, then in a region you have something called a VPC. VPC is short for Virtual Private Cloud. VPC is basically a part of the AWS network, which is specifically for certain customer, and you can create it, and it's like a software. It's a software-defined network, and it's isolated from the rest of the from the rest of the AWS infrastructure and network. Within a VPC, you have so-called availability zones. Here we have 2, availability zone A and B. And these availability zones usually come with their own subnet. Yeah? And you can have private and public subnets. And within a subnet, you then can instantiate a AWS EC2 instances, which are virtual machines. And virtual machines come in different flavors. Yeah, you have these so-called families. You have, for instance, T1, which is a instance type which is good for its bursting capacity, so it can easily adjust to very different needs. Or you have the M3, or you have a huge list of different kind of virtual machine family types. And then you can have, for higher availability, you can have virtual machines in different different subnets. And then you can combine it with something called auto-scaling groups, which make sure that you, for instance, have at least one virtual machine in one subnet, or you can configure it to scale up from 2 to 10, depending on certain rules you can define, policies. And then you can have something called a load balancer. And the load balancers at AWS come also in different flavors. You have an application load balancer, you have networking load balancer, and elastic load balancer. And we come to the details of these kind of load balancers later. And if you have these more and more complex kind of infrastructures which you deploy to AWS, automation is really important. And so AWS has its own solution for automating stuff. I mean, probably you all are familiar with tools like Puppet or Chef or Ansible. CloudFormation is the equivalent to these tools in the AWS universe. It's about infrastructure as code, yeah. So every time you describe a AWS infrastructure with CloudFormation, you basically have code, and it looks like this, right? You have a JSON file with a declaration of different attributes. You have a certain syntax. This one is, for instance, for describing a instance, a EC2 instance, and it describes in which availability zone it is. It describes which image ID it uses, and all these kind of things which are important when you start up a virtual machine. Another very important service at AWS is identity and access management. It's basically a service which allows you to define rules who can access what at AWS, and it is like a nervous system distributed through all these services which you have at AWS, right? So currently we have about 100 services at AWS which you can use as a customer, and IAM is, with IAM you are able to configure when and who and what somebody can do with services. IAM policies are also defined with JSON. Here we define a policy which allows the access to a 3 bucket, and then you have this actions which you are allowed to do as a user of this policy. And policies are not only for people who are using AWS. You have policies for Lambda functions which access certain resources. You have policies for EC2 servers which access certain services. So this is very broad in scope. Well, when it comes to Docker, it's kind of difficult to see where Docker is in the huge list of AWS services. It's a bit like finding a whale in the sea. You have so many different services, but it's not really apparent where Docker, what Docker is here. And that's why we have this talk. I'm gonna look with you at the different options which we have here. And they are more and more. The simplest use case for Docker is basically running it on a single virtual machine. On a single virtual machine, you are able to at least run some containers, and that's basically this case where you have this one virtual machine. And to get started on a single virtual machine is you could, for instance, just use a so-called Amazon Linux AMI. There are 2 versions, 1 and 2, and you can just spin a virtual machine up and install Docker on it with a yum update and then yum install Docker. If you have any other kinds of operating systems, and it's pretty easy too. You could use, for instance, this curl command, which basically sets up a Docker repository for your operating system and then installs Docker. Another way is also to use Docker machine, which is pretty simple. Yeah, you just say Docker machine create. You provide the driver name and then give it a name, and then it just creates a virtual machine at AWS. And then you can evaluate the environment variables, and then you can work on that machine as if you were directly on it. Yeah. Who knows Docker machine here? Yeah. Some. Okay, great. Another option for a single virtual machine is to use a optimized AMI from AWS. It's provided on the marketplace, so you wouldn't find it in the standard list of AMIs. And yeah, this already includes Docker, right? So you don't have to install anything. Well, then the next thing is, instead of just running one virtual machine, you run multiple virtual machines. Yeah, probably you roll your own cluster, yeah, and then you're able to run some more containers. One of the options you might think of then is Docker CE, yeah, Docker for AWS. Docker for AWS is a product by Docker itself. Yeah, basically has nothing to do with AWS. And Docker for Amazon comes in two flavors. The first flavor is Docker CE, and Docker CE stands for Community Edition. And Community Edition is basically a Docker swarm, which is highly integrated and optimized and integrated for the AWS platform. Docker CE basically is a CloudFormation template, and you can start it from this website, for instance, on the Docker documentation page. And when you start this, or when you click on that link, you will get this page here. Here you basically start a so-called stack. Yeah, stack is basically a couple. Yeah, it's a CloudFormation term, and it is a collection of resources, and resources are all the things that CloudFormation basically creates for you at AWS. And when you start this CloudFormation template for Docker CE, you have a couple of parameters you can fill in. And the important ones are basically you give it a name, you say how many swarm managers you want, and you say how many worker nodes you want. Yeah? And then you have some other properties like providing your SSH key and then these kind of things, so you can access these nodes later. And when you start this, CloudFormation starts to create the stack. Yeah, we see here, create stack is in progress. And then we have all these different resources which are created for us. Yeah. So basically, who did already set up a Docker swarm himself? Is there anybody? Do you have some experience? So basically, setting up Docker swarm is not so complicated. It's pretty easy, at least compared to Kubernetes. And what you also here get is you get integration with the AWS backend. Yeah? And we see here, after the stack was created, we have a couple of EC2 instances which are all running. And if we look at the kind of architecture the stack created, we see that it's basically a highly available architecture. Yeah? We have 3 availability zones. And then we have the masters in each of these availability zones and our 2 worker nodes. Yeah? And both are set up to use autoscaling groups that makes it possible to change the autoscaling settings or adjust, to add policies which basically help us to scale this cluster dynamically up and down depending on the workload. And in front of this is a elastic load balancer. So this all is basically set up by this CloudFormation template in about 10 minutes. It's really easy. And when you look at the configuration for this load balancer, you will see here that you have a DNS name, which is also setup for you. And then you can basically add a Route 53, which is a domain name service of AWS. You can add a Route 53 domain name connected to this load balancer name, and then you are basically all set and are able to use it. Yeah, that's Docker CE. And then there's this other product called Docker Enterprise Edition. And Docker Enterprise Edition is basically a Docker CE plus some things. Yeah? You get a couple of additional things with Docker Enterprise. You get something called a Unified Control Panel. Unified Control Panel is basically a management console, web-based management console to manage your Docker Enterprise installation. You get RBAC and LDAP support. RBAC means you can configure user and teams and roles and can give users access to different parts of your cluster, yeah, and then you can integrate it with your LDAP in the company. Then you get security scanning. That's basically the ability of scanning the images you create for some kind of vulnerabilities. And then you have the Docker Trusted Registry, which is private Docker Hub basically. And you have image management for automatically cleaning up old images and these kind of things. And then probably for many companies, it's also important you get professional support. And that's basically what differentiates Docker Enterprise from Docker CE. This is the web console, the management console for Docker Enterprise, and you basically see here just from the navigation what kind of operations you are able to do with this installation. Yeah, then the next option to run containers on AWS with a couple of virtual machines is Kubernetes. Unfortunately, right now there is no managed Kubernetes service on AWS, unlike with Google Cloud, and you have to basically roll your own Kubernetes. Amazon mentions that basically 63% of all Kubernetes installations run on AWS, and one way to create your own Kubernetes installation on AWS in a production-ready kind of way is to use kops. Has anybody heard of kops before here? Some of you? Okay. Kops makes it really easy to set up a production-grade Kubernetes cluster. It has a couple of features, like deploying highly available Kubernetes masters. In the end, it's basically a similar kind of architecture we've just seen with Docker's Enterprise or Docker CE. And what I especially like is the ability that it kind of can generate Terraform templates, and it also can create CloudFormation templates. So you basically are able to create these kind of templates, put them into your version control, modify them, and then roll them out without kops. When you use kops, you basically have 3 steps until you have a running cluster. First, you need to export or give it access to your AWS profile. So it's basically your credentials you have for your AWS account. Then you need to configure, create and configure a S3 bucket where it stores its configuration data. And then we give it a name. And then basically the second step is already to create the cluster. It's one command. And if we look at the different parts of the commands, basically we provide also the amount of nodes we have, the amount of master nodes, the size of the different instances we want to use, and the kind of networking we want to have, the topology, and in this case also I say I want to have a bastion host in front of my cluster. And then I just do a kops update, and then it starts to create this cluster. And then it takes like maybe 15 to 20 minutes. And then I'm able to say kops validate. Kops validate just checks that the connection is possible to my cluster, and then it gives me a overview of all the nodes in my cluster and how they are configured and how their status is. So here everything went fine, and afterwards when I want to get rid of the installation again, I just can say kops delete. Yeah, and it creates this architecture, yeah? Just like I just explained. We have 5 nodes, 3 master nodes, 2 worker nodes, and a bastion host, which we can access with SSH. And all the stuff which is necessary to make this possible is automatically set up by kops. There is another project called AWS, which has a similar scope to KOP. Yeah, and I think they are already in talks also to maybe join efforts and fuse kops and AWS. Yeah, so we had single virtual machines, we had multiple virtual machines, and what's now, we go beyond virtual machines. We want to have a container as a service. Yeah, and AWS has us covered. Yeah, there's a service called Amazon ECS, and ECS stands for Elastic Container Service. Yeah, and Elastic Container Service basically provides a managed container orchestration for us. Yeah, it basically looks like this. That's way too far. Here. That's basically the managed part. Yeah. Amazon ECS. We have things which you might have seen with other kind of orchestration tools. Yeah, we have a key value store, we have a cluster management engine, and we have a API and a communication service. And then we have EC2 instances, right? Here we have 1 instance, another 3 instances in 2 different availability zones. And on each of these instances we have a agent, yeah, the ECS agent. And the ECS agent basically does the communication with the orchestration engine. And is responsible, and basically the ECS is responsible for placing and scheduling then containers on these different instances. You can create your own AMIs, yeah, so you don't have to use the provided AMIs from AWS to create these instances. You can create your own AMIs, and then you just have to install the ECS agent on these AMIs. What's also important is that you basically only pay for the running instances. Yeah? The service, ECS itself, is completely free. You pay for the instances which basically are your worker nodes in this architecture. What makes it a little bit weird in the beginning to work with ECS is that it has its own kind of terms, yeah, for different things. So even if you are familiar with Docker, Docker Swarm, or Kubernetes, it might be a little bit strange in the beginning. So we're going to look at some of these terms. So we have a cluster. A cluster in ECS is just a pool of worker nodes. Yeah. Then we have the scheduler. A scheduler is attached to a cluster and is responsible for placing and scheduling containers on available instances. Then we have something called a task definition. And the task definition is basically similar to what you might know from Kubernetes or from Docker Compose maybe. It's a definition of the different containers which belong together. And then we have tasks, and tasks are actually the kind of instantiated task definitions, yeah, the actual containers running on the cluster. We have support for 2 operating systems, yeah, so we don't have only support for Linux, we have support for Windows also, since yeah, I think a couple of months. And yeah, with ECS, yeah, the standard mode basically is or was for a long time to manage your own EC2 instances. And in 2017, in December, at the reInvent conference, AWS introduced a new service called AWS Fargate. And AWS Fargate has this mission to provide a managed container service which is on a higher abstraction level than ECS. So you don't have to manage your own instances anymore, right? And then they also introduced another service called EKS, which is a managed Kubernetes service, right? So far, I wasn't able to get into the preview. It's in preview so far, the EKS service. And despite being an enterprise customer of AWS, we weren't able to get into the preview. But I can tell you some things I picked up in the last couple of months about EKS. What AWS provides basically is a control plane where your master nodes, yeah, are managed by AWS, and all these master nodes also run in different availability zones. Yeah, exactly. They run in exactly 3 availability zones. So you have a highly available cluster. You don't have to manage this cluster, and this cluster runs a upstream Kubernetes. So you're able to use all your standard open source tooling for Kubernetes and access this cluster, right? And then, yeah, and then you basically also get the same possibility with EKS as you got or get with ECS. Yeah, you get access to the Fargate service, and the Fargate service, same as for ECS, makes it possible that you don't have to manage your worker nodes too. Yeah, to wrap it up, I mean, we just walked through the different options to run containers on AWS, and just getting the kind of technology set up and running is not everything you need when you want to run production workloads, right? It's not just like you install Docker Swarm or you just install Docker, you install Kubernetes and then you're set. No. You usually have a lot of other aspects which you need to take care of. Yeah. For instance, you need to think about logging, yeah, or you need to think about monitoring. Yeah, how do you gonna monitor your cluster? You need to think about alerts and alarms. Yeah, when something goes wrong, or you want to auto scale, for instance. Yeah, so that's also very important. You want something which is able to self-heal itself. Yeah, when some node is crashing, and then you also want to have some kind of service discovery, right? And you want to maybe manage your secrets. Yeah, maybe you're even using applications which adhere to the 12-factor app paradigm. And then, of course, you just want to make sure that only these people who are allowed to access this cluster are able to access the cluster. Yeah, you want to make sure that only certain ports are open for your cluster and all this kind of stuff. And the different options, yeah, kind of differ quite a lot when it comes to these different aspects I just mentioned. Yeah. So the question is, what do you use, or what should you use? Basically, it's a decision based on the kind of workload you have. Yeah. Do you have a workload which is kind of fixed, or do you have a workload which is very flexible and changes a lot? Yeah. Probably you're gonna have different. You might want to use different solutions for that. The kind of resource constraints you have, yeah, like money, knowledge, yeah, and time. Yeah? If you don't have time, you probably want to go with something which is easy and to set up and to get started. And then there's also complexity. Yeah? Everybody who set up a production-grade Kubernetes cluster knows that it's not a piece of cake, and that there are a lot of things to do until you are really finished with such a setup. And then there's control. For instance, if you look at higher level services like ECS, with Fargate, you don't have any control on the Docker version which are used on your hosts, because the EC2 instances are managed by AWS. And if that's important to you, you might need to go with a different solution. And then, of course, if you are, for instance, are already on AWS with your applications, it might be very important for you to have AWS integration, to have a deep AWS integration. So that's basically a number of criteria you can apply to find the best solution for yourself. Virtual machines, which you just run, obviously are the ones where you have the least kind of integration, and then you have the different options like running your own cluster with Docker CE or Docker Enterprise, where you have more integration, and then at the end of the spectrum you have Docker, you have ECS with a very deep integration into the AWS ecosystem. So that's basically the overview of the different options we have at AWS. In 2018, we have quite a lot of these, and I think that's a good thing, because choice is good. No use case fits everybody, and so well, that's it. Thank you.